Hello, students. Today we're going to talk about the rules for graphing inequalities, and we will talk about solving inequalities. So first, you need to know that we will use an open circle for less than or greater than signs. We will use a closed circle for less than or equal to or greater than or equal to signs. So in our first inequality, we have x is less than 3. Carefully locate 3 on the number line, and I'm going to make a little open circle above the 3, and then I'm going to draw a line toward negative infinity, put an arrow on it, and that is how we graph x is less than 3. So here we have x is greater than negative 1. So let's locate negative 1. Always locate the number first. Here's our negative 1, open circle. If x is greater, then we need to graph in the direction of the right. Now, here's a little trick for you. If your variable is on the left of the inequality sign, always graph in the direction of the inequality sign. So if it points to the right, you'll graph to the right. Going back to number 1, and this only works if your variable is on the left, like we read from left to right. So if your variable is on the left, we graph in the direction of the inequality sign. Number 3, x is greater than or equal to 7. Let's find 7. Now, greater than or equal to is a solid dot or a solid circle, and we graph to the right. For number 4, x is less than or equal to negative 5. First, we will locate negative 5, make our circle, and our arrow. So pretty easy, I think. A little bit of practice, you'll get it really quick. Now, let's solve some inequalities because there are some things you need to remember. Oh, before we do that, we can look at a graph and we can write the inequality. So let's do a couple of those. So I see an open circle and I see the line extends toward the left. So we would say that x is less than negative 2. Number 6, we've got a solid dot on 4, and we have the graph extending to the right, so we will say x is, sorry about that, x is greater than or equal to positive 4. Number 7, we have a solid dot on 0 with the graph extending to the left. X is less than or equal to 0. And number 8, we have an open dot on negative 3, and the graph extends to the right, so that would be x is greater than negative 3. Okay, let's move on to solving some inequalities. Very important thing here. This you must remember, you must memorize. It's pretty easy, but I don't want you to forget. You must flip the inequality symbol when you multiply or divide by a negative number. Other than this one rule, inequalities are solved just like equations. So the first thing we'll do is isolate the term with x. So we're going to isolate 3x by subtracting 2 from both sides. This would cancel. 3x is less than negative 6. Now we're going to divide both sides by 3. 3 over 3 cancel and equal 1, which gives us x is less than negative 2. That's our final answer. So let's graph this. We'll make this a 0, 1, and here's our negative 1, negative 2, negative 3, negative 4, negative 5. Okay, we're going to have an open circle above the negative 2, and our graph will extend to the left. Okay, we have x divided by 6 plus 2 is greater than negative 1. First, we need to isolate this term. And in order to isolate this term, we will subtract 2 from both sides. Remember, we're performing inverse operations. Positive 2 and negative 2 cancel. That gives us x divided by 6 is greater than negative 3. Now, we're going to multiply both sides by 6. Let me change the color so I can kind of make it show up a little better for you, so you can see the steps. So we'll multiply both sides by 6. You notice how I use parentheses. We did not multiply by a negative, so our inequality sign stays exactly where it is. Negative 3 times 6 is negative 18. The 6 over 6 cancel. We have x is greater than negative 18. So let's think carefully how we want to write this down. Let's start with negative 21, negative 20, negative 19, negative 18, negative 17, negative 16, negative 15, open circle on negative 18, and we will graph to the left. All right, let's try number 11. We have a negative 7 next to our variable. So we're going to have to flip the inequality sign when we do this problem. So first we need to subtract 8 from both sides. And it's really important when you do these, students, that you remember all your rules for multiplying and dividing positive and negative numbers. So positive 8 and negative 8 cancel out. Let's bring down our inequality sign. And let's bring down our negative 7x. We haven't multiplied or divided anything yet, so the inequality sign stays the same. So now 1 minus 8 is negative 7. Now we are going to change the color so you can see the steps. So now we are going to divide both sides of the inequality by negative 7 in order to isolate that x. Because we did that, we need to flip the inequality sign, and we will have now x is greater than or equal to 1, because negative 7 divided by negative 7 is 1. So let's start with negative 2, negative 1, 0, 1, 2, 3, 4. And we'll have, because it's greater than or equal to, we'll have a solid dot, and we will graph to the right. Let's do another one with our variable being divided. First thing we need to do is add 5 to both sides of the inequality. Negative 5 and a positive 5 cancel. Let's find another color here so we can show all of our steps. So now I'm going to bring down the x divided by 8. I haven't actually divided by anything yet, so I'm not changing the inequality yet, is less than negative 2 plus 5 is 3. Let's change the color again. And now we're going to multiply both sides by -8. And -8 divided by -8 cancel because they equal 1. When we have x, we flip the inequality, is greater than -24. And I think I will start with -27. You have to be careful where you start these number lines so that you can graph them. 26, -25, -24, -23, -22, -21. We have an open dot with our graph to the right. So go ahead and try the rest of the page. You have a couple tricky ones here. Let me do number 19 for you before I let you off on your own. So what we have here is 4 minus 1/3 x is greater than 11. So what we have here is an invisible positive sign. This is a +4. So the first thing we want to do is we want to isolate this term. So we need to subtract the 4, and whatever we do to one side of an equation or inequality, we do to the other side. The scales of algebra justice must always be in balance. Let's find another color. And the 4/4 will cancel. +4 minus 4 cancels, becomes 0. Now I have -1/3 x is greater than 7. 11 minus 4 is 7. Now I have yet another step to do. I'm going to divide by -3. So I'm putting the negative sign with this denominator here. Divide by -3. Whatever I do to one side of an inequality, I need to do to the other. Now I'm dividing by a negative, so I need to flip the inequality symbol. So -3 divided by -3 basically equals 1. And because we have a 1 in the numerator, all we have left is x. 1x is x. That's an invisible 1 there. X is less than 7 times -3 is -21. That's a final answer. And I'll start with -24, -23, -22, -21, -20, -19, -18. I will put an open circle on -21 and I will graph toward the left because remember this graph, this line here, this represents all of the values of x that are true and that will solve the inequality. So that's what we're looking at. We're looking at all the values of x that solve the inequality. So if you were to go back and you were to try to check your answer by substituting, you would have 4 minus 1/3, and then leave that open. That's our x value is greater than 11. And for this to be a true inequality, that true as in it's not false, as in it would work. Anything that happens over here would be greater than the 11. We can put any integer or even we could even put a fraction, anything in here as long as it's less than -21. Remember, because of the open circle, the solution does not include 21. That's what the open circle means. So anything less than -21 will work in here and make this inequality true. So try to finish these on your own. Good luck and do a good job on your homework tonight. I know you'll be great.